It's time.
Okay. We are going to start our meeting. Hello, everyone. It's the CATS meeting in IETF118, and we are Adrian and Peng as the co-chairs. Our AD is Jim Richard, and Cheng Li is our WG's secretary. Yes, you can find that every time we find CATS for you. And it's our third time meeting, so we find 3 cats as a gift for you. And for the note well, please remember that you are agreed to follow IETF process and the policies. And if you are aware any IETF contribution is covered by patents or patent applications, you must disclose that fact. And personal information that you provide to IETF will be handled in accordance with IETF policy statement. And the list below are more information as a BCP document. So we are asked by the ISG that please remember to show your respect to all of the colleagues at our rooms, and well, we are expected to have impersonal discussions, and we are working on the diverse solutions for the global internet, and meet the needs of diverse technical and operational environments. So we are individuals and contribute to our WG. And for the Meet Echo, we get a new version of the client, and we are using the queue control, and the chat is also available. So Cheng Li will help to take the minutes, but we expect that anyone could help to check the comments are recorded correctly. And here's our meeting tips. We have both in-person participants and remote participants. So for the in-person participants, please make sure to sign into the session using the Meet Echo, and keep audio and video off at all times because you are in the room. And you also need to use the Meet Echo to join the mic queue before you stand behind the mic queue. And for the remote participants, please make sure your audio and video are off until it is your turn to speak. So here are the deliverables and the milestones. All drafts are welcome. Please post them in the data tracker and discuss them on the mailing list before every meeting. Please remember that is critical. And the solution draft, now we find some solution draft that cite our WG's use case, but now we just to have a WG document as a use case and a requirement, but we don't have the framework WG draft until now. So setting CAS as a motivation is premature. And we have done the use case and requirement draft as a milestone, yes. And here's today's agenda. It is focused on the use case and requirement, framework and architecture, and the gap analysis. We will have 4 use cases, 2 framework draft, and 1 gap analysis presentation. And any comments on the agenda? Okay, so we are going to the first presentation.
Okay, thank you. Am I okay to share my screen?
Yeah, we'll just
Okay.
we'll just move on to the next slide set, and then we'll actually give you control of our slides rather than you doing share screen.
Okay, I mean there will be some animations that probably will miss, but but that should be okay.
Yes, we pass the slide control to you.
Thank you. Okay. Right, let's get started. Well, first of all, thank you for the opportunity to talk about use cases, especially the use case about AI for me. So I'm Rajiv Ramdani. I'm a senior R&D engineer at BBC R&D, and I'm a co-investigator in the AI for Me project. And I'll be giving an overview of the AI for Me project on behalf of my colleagues and also of Daniel King, who is actually in the room and who will be coming to the microphone, I think, at some point to contribute and answer questions. So we want to actually explain the network challenges that are experiencing in the project around the delivery of personalized media and how these challenges actually seem to overlap with network requirements, for the CATS working group. Uh, so first we'll actually probably talk about how the requirements for the AI film project are coming from real business needs and requirements from the BBC. And the BBC, as you know, is one of UK's largest public service broadcaster and probably one of the oldest in the world. And it has been engaged in continuous research as it tried to navigate its way in actually pushing most of its content online and delivered over IP and mobile networks. So it has been on a continuous path of research and innovation on every aspect of the broadcast chain, so like audiences, production, and distribution. And that history of innovation, has a number of notable milestones. Too long track history for me to kind of cover, but the BBC was like the first organization to do a public TV broadcast, so up like in 1937, and it has been kind of going through various innovations, like doing the first HD broadcasting, creating the first catch-up TV service over IP, trying to deliver content in new novel forms, for example, VR, immersive content, binaural audio, uh, delivering over new networks like delivering TV, AR, VR, 360 over 5G, contributing to standards, looking at how to improve the latency and the adaptation we can do over media streaming, for example, over HTTP and QUIC. And we recently won an Emmy for the work we have done on HDR. Okay, so so the AI Film project essentially is about delivering personalized and hyper-personalized media experiences at scale anywhere. So it is a collaborative project running over 5 years between the BBC, University of Surrey, and Lancaster University, and we are mostly trying to focus on building capabilities using AI techniques and tools that will allow us to kind of create and deliver the experiences. And we're focusing on actually three main areas. So, and these areas kind of reflect the different stages of preparation of content, production, and delivery. So, for today, I will be talking a little bit about object capture and representation, object-based production, and then on the delivery side, the compute-aware network delivery, where we think it has the most applicability to the CATS working group in terms of a use case. So, what underpins personalization and hyper-personalization is the concept of object-based media. And object-based media is quite suitable for this purpose because it allows the content of programs to change, to adapt to the requirements of the user. So a media object is basically an asset, any asset that you use to actually make the content. It can be audio tracks, video tracks, graphics, captions, 3D models, data streams, textures, can even be code like shaders. So in a traditional linear broadcast, for example, you would actually combine those, compose the different media objects in production, and then you would create probably one or two assemblies, and then broadcast that same assemblies to everyone. But with object-based media, you give the opportunity of that assembly to happen at consumption, at the point of consumption, based on the user preference and interaction, and you can actually make those experiments become interactive. Um, so in the first work package, so the work in the project that you were broken down into these different work packages, and each kind of focusing on those three different areas I mentioned. So in the first work package, we call it streams as well. So we're talking about creating media objects for personalization, and here we use AI-based techniques to extract objects and metadata from uh, existing and new audiovisual streams. So, for example, what we would do is, uh, given a particular scene, we will try to do active speaker detection and localization. So we might be able to crop a particular piece of video, create an object. We would actually analyze video scenes and build a semantic understanding and generate natural language descriptions of the scenes. And we might be able to delimit the boundaries of events or actions in the scene and create objects as well. And sometimes, because of the nature of capture, we are limited in the data set that we have. So we use like neural object rendering, for example, to build some neural object, so some neural network of objects in the scene, and then generate from your a set of 2D partial images. We generate novel views for a 3D scene. Um, And then in stream three, what we are looking at is essentially the production stage, and how do you combine those different objects together in all sorts of novel ways, but still maintaining the flexibility for the user. So here we actually playing around with AI-powered tools and techniques to allow producers, creators to create these personalized media experiences. For example, we would actually use an LLM or GPT kind of model to generate a weather forecast. So create the script, the narrative, feed that to a text-to-speech engine, generate the audio, uh, animate a synthetic human, for example, to actually deliver regional weather forecast. What is kind of key to understand is the degree of flexibility and adaptability that we need. So when we create those experiences, we really don't know the conditions in which they are going to be consumed. It could be in your living room, in a fairly quiet living room, or it could be on the train on a mobile network with a fairly noisy environment. So modeling quality degradation, encoding editorial intent is something that's kind of we are looking at as well. Now, probably more interesting to Dan and myself, we can work on stream 4. So we are looking at compute-aware network delivery. And here we want to actually deliver these personal media content cost effectively and efficiently to mass audiences. And in doing so, we want to utilize compute where it's available. And so we are focused on intelligently provisioning compute and orchestrating our services on those compute. We are very much driven by uh, keeping costs down. So sublinear scaling is another key area we are focusing on. And as we kind of run these particular distributed media pipelines, we know that things can change. You might have suboptimal pipelines. So we want to look at a solution that will allow us to do real-time adaptation optimization. So to kind of add a little bit of motivation and context to this kind of area of work that's driving stream 4. So we know that personal media application will actually need compute. Very often, re-rendering content actually requires GPUs or compute. And personalization increases the chance of actually having to do re-rendering or reprocessing, especially if you have interactive experiences. And for the BBC, we know that that compute might not be available in the end devices of the users, because we don't see compute materializing fast enough in those end devices. So to actually achieve universal access, we kind of looking at ways where we can offload compute to the cloud. But we know that offloading compute to the cloud can be prohibitively expensive. I mean, if we consider the case of cloud rendering, where you would dedicate a GPU per user, for example, delivering a 1 hour program per day to 20 million people would outstrip by 4 times the entire expenditure on distribution for the BBC. So essentially what we want to do is to keep costs down, is make very efficient use of compute where it is available, right from the core data centers down to the mobile edge or edge sites, and trying to maximize also what we can use on the user devices as compute resources. So what the animation would have shown is uh, it is not just kind of utilizing compute resources where they're available, but we would have migration of services from the core to the edge where it makes sense to actually look at that computation. For example, if you want to do regionalization of a particular unit personalized per region, it would make sense to actually push that service further down on the edge rather than actually push all your backhaul traffic or your processing load onto your core infrastructure. What you would also do is, whenever you have those compute fragments running on your on your device as your media applications, if the device is not capable, you could migrate those green boxes, as you say, to your mobile edge further upstream to give a better quality of experience to the user. Um, Now, to achieve this presents us with a number of challenges. For example, uh, our applications, they need predictable connectivity to compute resources to actually offload compute fragments. And we kind of realize that, as you've seen, we need the flexibility of migrating compute uh, up and down the delivery chain. This contemporary approach of statically assigning compute to centralized cloud locations or to the device, it doesn't work for AI for me. We we see that compute and storage nodes should be able to move very freely along the entire delivery pipeline. And the time is ripe for this because we see a lot of enablers that will make this possible. We see, availability of data centers at different parts of the network, virtualization of hardware resources, uh, cloud gaming technology, software-defined networking, traffic steering, for example. But we realize that this is not just enough. The decision to move compute uh, in a very large distributed system is quite complex. And this needs to be done in real time as well, because a deployment that we make can quickly become suboptimal, and it needs to be kind of reevaluated and and adapted in real time. So to kind of give probably an idea of what we mean by those deployments, and so let's consider a couple of permutations. So here we have a typical object-based media uh, deployment where we have a relatively powerful user device that can do a substantial amount of processing, and then we have like 4 media objects, and we can actually compose those 4 media objects on the device. So this is kind of a fairly simple approach. To scale this up, we just need to throw some more CDN cells, caching cells, for example, and we should be okay. But for more compute intensive type of media application, this becomes a little bit more challenging. especially if we have low-end devices, and we want to actually have nearly the same level of functionality on those devices. Let's consider a use case where you have a user navigating around a 3D scene. So now, because the device is not that capable, you might want to actually move that rendering to the edge. So here we have some mockup data which is actually being streamed to the edge, and that mockup data is used to drive an avatar animation, and that the avatar animation is used kind of then is rendered, and then we are composing that avatar with a number of other objects. So the interactivity that we might have in this use case will also kind of add some more constraints of where we can actually offload this kind of compute. Um, in terms of the use cases we are actually implementing in AI for me, I will mention a couple of them. So we have weather forecaster as an object-based weather forecast experience where the user can choose between different personalization options. Some of them are explicit, some of them are implicit because the content will implicitly adapt to the device. So at the bottom of the screen, you will see like the number of personalization options where the user can select between a signer or the normal presenter, change subtitles, even have subtitles translation, or you can even change the presenter to a child version of you know of a presenter or like an animated character. Or for visually impaired people, you can switch to the high contrast weather map in the background. So we have implemented a number of deployment and permutations of those deployments. And what you will see here is at the bottom, the list of personal options translate to a number of services. And some of the services, they govern the presentation of those different objects. Some of them are renderers or compositors, synthetic presenter kind of generation, for example. Some of them handle user input. So um, the first device, as you see, the compositor client device here is fairly capable. So it's running rendering and composition on the device. And then as more and more devices arrive, we might end up with a device that is not capable at all. And there you will have to offload the rendering to the edge. So we have here on the if I can read that on the not the core, but on the middle data center there. So you would have, for example, a lot of the service instances actually running. And then the rendering is done there, and the result is actually pixel streamed to the client device. You might have a slightly capable device that can do most of the computation, but you might offload the map rendering, for example. And so, for example, you see that at the mobile edge, we have the map rendering, which is happening. But as you kind of evolve your delivery pipeline, you might take advantage of computations being done. So, for example, these two boxes on the mobile edge can move to the middle data center where you can actually multiplex many users on the same services. We are looking at also some more compute intensive use cases. So for example, we have a Radio 1 program at the BBC called Live Lounge, where we have artists performing. So we aim at putting them in 3D environments, in volumetric captures, making of studio sets and rendering those, even have AR kind of type of experiences where you can actually put the artist in your kitchen. In terms of resources, so if we translate what those services you saw in terms of things we really need to ensure that we are able to smoothly deliver these high quality kind of streaming experiences. We think that, okay, we have those service instances, there's content servers that will actually process media, generate media, stream media. We need storage, content storage. We need caches, for example. We need CDN components. We need content encoders. We need low latency pixel streaming to client devices. And we need GPUs, of course, whether it's to do rendering or machine learning based in inferencing. So these are examples of some of these kind of capabilities and resources that we need. And if you were to kind of organize this into a high-level architecture, then it would look like this, where we will run our services on compute resources available across the chain, uh, and strategically making decisions on where to actually put a renderer, where to put a compositor, when to actually move some of the services from one node to the other. So we think that this architecture side and those services, there are two additional components which is needed. So we need a cloud orchestrator and a network controller. These are going to govern where we actually run things and how clients are going to connect to them. But for them to make these decisions, we do need a number of different metrics. So we do need to know where the compute resources are available, where they have been provisioned ahead of time, or what is the provisioning delay, for example. And we do need to know about response time, latency to that compute resource. We do need to know real-time usage metrics. What's the memory pressure? What's the GPU pressure? What's the CPU pressure? We want to know how many users a service instance can actually support, and how many users are actually being running on that particular service. IO speed for storage, for example, maximum connection supported, network latency, jitter, bandwidth. In terms of the caching, what's the caching performance, the miss rate, the fetch latency, for example, the throughput of that particular cache. So all these are really important metrics that we need in our decision engine to do intelligent placement. And so we talk about these two kind of possible components. We have a cloud orchestrator, which actually decides on the placement of the service instances, so the deployments. So as you kind of have jobs streaming in from your client devices, uh, their computational demands are going to be identified, and the cloud orchestrator will assign users to particular uh, service instances based on the metrics that I mentioned before. And then a network controller will actually direct traffic coming from the user to that particular service instance, ensuring that we're reducing user latency, and we are able to optimize content delivery. So in terms of our requirements for CATS, essentially, we have identified a number of compute metrics, right? And it would be kind of good to agree on a standard set of metrics uh, and on standard ways of actually collecting and distributing them. We will quite likely be interacting with a number of compute providers, cloud providers. So what do those cloud platforms report as a standard set of metrics is important. We now have a delivery chain that involves not just a network, but compute as well. So we need a standard set of metrics and standard way of actually collecting and distributing them. Uh, so then, can we agree on certain kind of architectural models? Uh, can we agree on what metrics we'll be able to get from the network, which metrics we'll be able to actually will have to provide as part of a service instance, and how those metrics will be collected and where they will be stored, where will be distributed? Okay. Um, And we kind of showed a high level architecture really. So we really want to know how our network architecture and our AI from service kind of model overlap with existing IETF CATS objectives. So we see there is some community requirements, but we want to ask people in the audience, and the question is, do we want to actually what's the approach here? Do we document our use case, AI for me as internet draft, or do we contribute to existing use cases? And that would be all from me. So if you have any questions, I think myself and Dan would be quite happy to answer your questions.
So thanks, Rajiv. It's always interesting and valuable to get a sort of wider view of concrete use cases. We have a nice line of people. First up is Tom Hill.
Hi, Rajiv. Tom Hill from British Telecom. The network, I think, on page number 9 looks a lot like the one I run. So I was interested to see lots of GPUs in there. I think that's interesting, to say the least. However, I firstly wanted to double check if, had you engaged with anyone at British BT about this at all? And would you like to?
We have been in talk with at least a person called Andy Gower, but mostly on the object-based media preparation or content preparation side. But
Sure.
we would really love to talk to actually people who actually look at virtual network function, like network virtualization, that will allow us to actually create those compute sites at the edge.
Okay, so because that's quite a large conversation. I think separate to that though, what I really wanted to ask about in relation to CATS was, how do you see your metric sharing manifesting in a fashion? Do you think that this is something that would be built into an over the top or an out of band channel sort of signaling on the side, or do you think that there is some change to internet protocols or data path that needs to be done to achieve what you're hoping to build?
Yeah. So I'll try to answer this, and if Dan is there, he can also answer it. So I think right now, I think that the answer is we don't know, because we are playing around with these different deployments and trying to come up with architectures where we can actually collect metrics and make those edge decisions about where to push compute. So we don't know yet. So it could be actually in band, or it could be some sort of as part of some smart CDN kind of functionality, maybe.
Okay.
Maybe Dan, you can answer this question.
Hi there, Dan at Lancaster. So as Rajiv kind of pointed out, we're still exploring options, and indeed the architecture is kind of fluid itself. What we didn't want to get embroiled in is what the underlay looks like. What we're primarily focused on is really how we can get metrics both out of the network and from the cloud nodes, and then how they can be used to ensure that the users are attached to points that will deliver the experience required. And in terms of direct CATS applicability, maybe the job scheduler, certainly the metrics definition, how we exchange metrics between the provider of the connectivity and even the host that has the compute resources. The BBC will operate islands of DC themselves, but it's anticipated that several additional sites close to particular users where the BBC doesn't have physical infrastructure for the data center, we'll have sort of peering agreements with, and we'd need to understand what the current utilization, availability, and some of the scheduling as well would also be exposed.
Okay, thank you for the clarification, and I'll reach out to you, Rajiv.
That's good. Thank you.
Daniel, the other one.
Okay. Daniel Huang, NCT. from your use case, I understand that here are two scenarios. The first one is about service instance to deployment, where you want to optimize the deployment based upon the matrix from service and network. But under this scenario, actually, there's no traffic steering right here, only about the deployment. And the metrics of networking and computing is quite comparatively would be quite dynamic. And when it comes to the service traffic steering, I believe the metrics you collect from both the computing side and networking side would be far more dynamic. So I'm not sure if whether or not we can have a common set of metrics for the two scenarios, and also I'm not sure whether or not CATS can do to address the requirements of the deployment, the service deployment. Thank you.
Okay. Yeah. So we actually, of course, want to know the current conditions for actually to be able to predict the quality experience of the user at the user end. So for that, we need to know about network latency, bandwidth, jitter, and all that, at least between a potential service instance and that particular user. And as kind of you said that as things will actually evolve and change, what we also do is in real time monitor what's going on with the network connection between the user and the service instance, and adapt the content. So we kind of have quality ladders where we adapt the content to be delivered to the user. Okay, yeah, we will actually try to kind of differentiate between those different metrics needed for those two different phases.
Chung Lee from Huawei. So first of all, many thanks to your presentation. It's really interesting to me. So could I invite you to share some information in the mailing list, or let's discuss in the mailing list to see whether we can add this kind of scenarios into the use case draft, because I think this is a very interesting use case that we might implement and deploy in the short term. Thank you.
Thank you. Yeah, I think we're quite happy to do that.
Yeah, that's perfect.
So Wei Ching, I had closed the queue, but if you're really quick.
Yeah, very quick. So one quick question. So from the architecture, it seems that the network node doesn't need a wire of the computing metrics, right? You just need the orchestration knows the metric. Is that correct?
Could you repeat that?
The network nodes don't need a wire of the computing metric, but the orchestrator need to understand the computing orchestrators. Right?
Okay. Yes. So I think the orchestrator is doing the matching between your compute requirements and then with the compute resources that you've got. And the network controller, so you might have, two-level decision making. So you might have a decision making which is done by the orchestrator to do your initial placement. But as things evolve, you might have your network controller steering the user to one or other service instances. So it's something that we haven't really explored that deeply, and we won't actually understand those demarcation of responsibilities, for which, and then what would be the metrics needed for them to make those decisions.
Okay, thank you.
Brilliant. Thank you, Rajiv. Hope you stay around for the rest of the meeting, and we can push forward with this to try to understand better what the overlaps are and where CATS can help with your problem space.
Yeah, thank you. I look forward to more conversations on the topic.
Okay, so next is a matrix with auto. Jody, please.
Thanks. Yeah, so Jordi from Qualcomm. Yeah, and actually the presentation from Rajiv provides, I think, a wonderful context for this other presentation as well. So thank you very much. This is about exposure of communication and compute information for infrastructure-aware service deployment and selection. There's a draft we posted, the first one, operational compute metrics. But there's also a draft actually that's back from 2019, which was submitted as part of the ALTO working group, positioning the idea of exposing compute metrics for some of the use cases actually that we're describing today actually. So, and then there's also a side meeting that we had a couple of days ago that many of you actually attended, where we focus on exposure of compute metrics. So there is a GitHub repo, and I'll probably update the slides with that information. So if you want to go next, thanks. Just to skip, we can go to the next one actually. I'm going to try to be brief and just probably focus on 2 or 3 slides only, so that we can have a few minutes for getting some feedback. But the problem space is as follows. And to position the problem here, we're looking at a very simple model, but which is the life cycle of a service. And to keep it simple, we're just looking at 2 stages. When you have a service, first you need to deploy it. And after it's deployed, then you need to run it and instantiate it and connect to it from the end user to the service instances. So looking at this full life cycle helps us understand the whole problem space. Service deployment, stage 1, the action to take is basically to place the service itself. So you need to know where is the compute, GPU, CPU information, and where is how much available bandwidth and latency, all these metrics that we need to extract in order to make informed decisions on how we place the service. Who needs this information? So typically the service provider. And this is, and I position here, or we position here, some working groups that are looking at this or have been looking at this historically. The ALTO working group, as I mentioned, ALTO application layer traffic optimization. So it's about exposing information from the network to the application so that the application can make informed decisions. Second stage of the life cycle would be service selection. And this involves usually a couple of things. One is selecting the service. So now the user wants to connect to that service. The service is already deployed. So which one, usually might have replication of services, so you can decide where to connect to. And then also the path selection problem, which path to get there, basically. This requires, again, compute and communication information in order to make an informed decision. And who needs this information? Could be at both levels here. The network provider itself, which is what CATS is working on, and the ingress port router, figuring out how to connect to the egress. And then also exposing to the application, because the application itself, whether it's a client or a proxy on behalf of the application, could use this information to also make a better informed decision how to connect. So that's the problem space. We can go to the next one, I think. And what we really like to get feedback on is, to be very practical, is on these 4 questions. I'm just going to state them. Question 1 is it likely viable that the network can expose communication and computing information to the service provider and application? Question 2, are there gaps in the entire service lifecycle, deployment, instantiation, selection, that are not currently being addressed and that are relevant? Question 3, would it make sense to define a common set of communication and compute metrics to address the various service lifecycle stages? And question 4, if so, where should this work be being held? A good fraction of this work is being held at CATS. Is this the place to expand this work, or should there be other options? So with these 4 questions in mind, and maybe while the audience thinks a little bit about this, just one more slide. I'm going to skip through. Maybe if you could go next, one more. Thanks. Yeah, some use cases. We can go next. And next. Thanks. So just to position a little bit more where we are in this conversation, IETF117, Adrian presented the potential idea of working together, CATS, ALTO, and defining these metrics, given the common ground. If we look at the CATS charter, the goal is to develop these metrics, part of the goal, so that the network itself can make these decisions, informed decisions. CATS very clearly specifies that the network and compute conditions exposure to the applications is not in the scope of CATS. And here, as we saw in the life cycle of the service deployment, some of these metrics would be useful to expose to the service provider to make these informed decisions. So that could be a potential gap. And the question is, how do we cover that? And so then there's this pointed to the slide deck by Adrian, which I think connects very well to the two sides. And this sets sort of the context. There was the idea of potentially having a side, having an interim meeting to continue this conversation. So with this context, then maybe the next slide, and then these are some principles. Very briefly, we're looking at two principles, which is on one hand, avoiding reinventing the wheel. So we can leverage the work that has been done or it's in the process of being done, don't replicate that. And the second principle, which is kind of like the dual of this principle, is avoiding gaps, making sure we take a comprehensive approach, a comprehensive view of these metrics that we define. While in some cases might be different, they have some commonalities, and making sure that the design takes into account things like the full life cycle of the service. And then next one, I think it's just to conclude, back to the questions, and I don't know if there are any comments or feedback.
I'm going to ask a quick unscientific show of hands here. Who in the room is sufficiently interested in compute metrics that they would review drafts? Okay, thanks. Who in the room is sufficiently interested in compute metrics that they would actually do active work writing documents? Lovely, thank you. And who in the room is so interested in compute metrics that they would persuade their employer to give up their time and travel budget to come to a meeting dedicated to discussing compute metrics? Okay, and for those of you not in the room, that produced no hands, and this is really helpful to me. Hang Shi, you're in the queue.
Han from Huawei. I have one question. You talking about two phase. One phase is for the deployment phase. The other phase is kind of for the traffic steering phase. Do you think these two phases will use one unified computing metric model, or they are using separate computing metric model?
It seems to me that some metrics are going to be different, but some are going to be common. And in fact, it seems to me that they need to be in agreement, because the two stages are connected. So when you deploy a service, you deploy it so that it can be actually instantiated. And so at the time of instantiation, you want to make sure that whatever you deployed was deployed in a set of metrics that then the instantiation stage can also speak the same language. So it seems to me that, that there is a need to have a common language between the two stages.
Okay.
Anyone else?
Okay, sorry. One point. It mentioned a common set of metrics. Maybe it's don't refer to the same metrics to different usage, right? But just to let people work together to make a set of metrics, and because different usage may have use different metrics, but it also needs more discussion and more work in it, right?
Yeah, I think right. That's part of the conversation, and trying to get some consensus on this.
Okay, thanks for pushing this, Jordi. I was getting a bit depressed by the CATS metrics effort until very recently, when we started to get some emails exchanged on the list. Let's try and build on those and work out what really needs to be done and see how to take this forward.
Sounds good. All right, thanks.
So next up is Kihan.
Hi, everyone. I'm going to update some information about the working group document. I'm sorry about there are some problems in the displaying. So next slide, please. For the document use cases and the requirement document, so here are some major updates compared to the draft in the last meeting. We rewrite part of the introduction to avoid some verbal description in the introduction part. And also we have echoing some terminologies defined in the LDBC CATS framework document on the service related document, service related terminologies which have been reached on consensus in the last meeting. And also we will merge a computing aware AI large model use case provided by Ali Cloud after this meeting. And also we the major part is on the requirements part. Here are some updates on the service and the instance selection, and also some updates on the matrix definition. So I will go into details. So next slide, please. So these are the service-related terminologies echoed from the architecture document. I will not go into details because most of them are already reached on consensus in the last meeting. And also you can see that we have very detailed service definition, and also it's also some clarification on the document, on the terms. So next slide, please. One more thing to mention about terminology is that we received some comments on the in the previous documents, the network edge and edge computing in the document are not well clarified. So we have provided some clarification on the terms and also their relations. The relations with between the edge computing and the network edge, that the edge computing infrastructures connect to corporate networks through network edge entry or exit point. Next slide, please. So here are the major updates in the requirements part. So the first major requirement is about the service selection. So previously there are only 2 requirements. So we received the comments that like quickly selecting the service instance is not quantifiable and not sufficient for the service selection. So we have added 3 more requirements. So we should provide a timeout limitation for selecting the service instance, because this can provide some evidence that how we can quickly select the service instance. And also we must provide a method to determine the availability of a service instance, because if service instance is not available, it cannot provide the capability to schedule to traffic to steering these services. And the last one is we must provide a mechanism for solving the service contention problem when multiple service instances with the same service ID are all available to provide computing services. Here are the basic, when scheduling them, you can use the egress PE to contact to the service contact instance, and then scheduling different service instance. We need to consider 3 different requirements at the same time. Next slide, please. And then it goes to the matrix stuff. So first one is matrix distribution. So we add 1 more requirement on the matrix collection because even though the matrix collection is not within the CAS scope, but we should we received some comments that we really need this requirement providing a mechanism for matrix collection. So next slide, please. And also, like the previous talk about the matrix definition and usage, here are some ongoing debate in the list. So we provide a temporary version on the requirement that in addition to common matrix that are agreed by CAS components like processing delay, there should be some other ways for matrix definition, which is used for selection of service specific instance. So we try to avoid like the term flexible, because it's also vague expression. So, but we know that this requirement might not be perfect at the moment, but we hear about different voices on matrix definition, the list. So the talk discussion is still ongoing, and we will keep update the requirement on the matrix definition part. And also we must include a default action for the interoperation of the network nodes, which may or may not support the specific matrix. And here we avoid the description of the term flexible. The next slide, please. And about service instance affinity, that in the previous document, there are a lot of like similar description, like service continuity, service session continuity, and session persistence. So we think that basically what we want to do is that we want to instance affinity. So we unify all of these terms to instance affinity in the requirement part. So if you guys have think we really need to like move back to previous description, please provide some evidence in the list. Thanks. So next slide, please. So in terms of the use cases update, we will merge a computing aware AI large model use case, which has been discussed in the last meeting and achieved the overall consensus. So the use cases cover about 3 major scenarios that may be interest to CATS working group, like cloud edge co-inference, cloud edge device co-inference, and edge long inference. So next slide, please. For cloud edge co-inference, it's about that we need to deploy these models in the cloud and edge. They can coordinate each other because the models may be a relatively large model will be deployed in the cloud, and some customized model will be deployed at the edge. When scheduling, when model is deployed for inference, they need some AI specific computing infrastructures to finish the task. So this case is about cloud and edge co-inference. And next slide, please. And also in some cases that when there are some AI, embedded AI compute functions or AI compute modules within the devices. So we can also split the very large model and push some pruned model inside the device. So in this case, then the cloud and edge and the device can coordinate to make the inference together. So next slide, please. And in edge inference model, we only deploy the customized models in the edge. So in 3 different scenarios, we mostly cover the AI model inference scenario, which require different pieces of AI computing resources to deploy it in different scenarios and compute these tasks together. So next slide, please. Here are a very quick recap and the summarization of all outstanding comments received in the last meeting in IETF 117. We have made some point-to-point reflection on the comments. So our updates has been marked in blue, and there are some ongoing work and some further updates need to be done in the next meeting, and we mark them in red. So I will just quickly go through all of this. So for the first one, we see that there are some requirements are prescriptive. For example, ruling out of band methods with low latency justification, which does not clearly state why out-of-band is incompatible with low latency. So from our understanding that the low latency characteristic of CAS mechanism, which use in-band solution, is very intuitive. And it does mean that out-of-band method doesn't work well. So just in our scope, we focus on in-band solution. And also the mapping of a service ID to a specific address, we think this is very required and necessary, since the same service ID may be bound to different addresses, but it also depends on how the CAS architecture is designed. So, and also we have update some terms on the vague expression like quickly, selecting the instance, and also flexibility about the matrix definition. These are also mentioned in the previous when I introduced about the requirements. So, but yes, the most important thing is about the matrix definition stuff is still ongoing, and also the matrix collection and the service and the instance affinity we have updated, and also there are some further things we need to update in the next version of the document. Is first one is the use cases are too high level to derive specific requirements. Even though we will merge a new use case, but the correspondence between use cases and requirements really indeed need further updates. And also the security considerations are relatively high level, so we will also update the security part in the next version. And the format issue has been solved. So this is the overall requirements update in this version of the document. So next slide, please. So for the next step, we will update three major stuff. So the first one is the correspondence between the use case and requirement part, and the second one is the matrix definition requirement, and also some security-related requirements. So we'll come for more comments and questions. So, and also one more thing to mention is that we have opened a repository on GitHub. So I know that not all people like to, not all people like the way that editing on GitHub. But if you really prefer doing this, please feel free to raise pull requests on it. Thank you. Any questions?
3 people, 4 minutes. Jim.
Thanks. Yeah, Jim Guichard, no hats on. I did notice one thing that concerns me a little bit, and I don't know whether it's something that we need to consider from a working group perspective, but we've got this kind of like fluffy, high-level idea of determining compute metrics and deciding which particular service instance to use. Based upon those metrics, but we don't have any discussion that I can see of how you abstract a service instance or a service identifier to an actual service. In other words, service identifier as in and of itself is meaningless. We need to have some. Is that something that we're going to just assume somebody else is going to take care of that, the operator, whatever? They're going to know that service identifier 1 means particular service that they have with these parameters, or is that something that we're going to get bogged down in? The reason I mention this is that we had this discussion, as Adrian probably knows, in SFC working group many times, and we never really solved it. Thanks.
Yeah, thanks.
Yeah, and I think it's more complicated for us than with SFC, because I think for us, little clusters of packets need to go to a particular service instance. With SFC, it was like just all packets. So it's a bigger problem. Joel.
Joel Halpern with Ericsson. Thank you for the presentation. You don't need to page back, but you had a slide in which you talked about a requirement that I will paraphrase as default interpretation of metric. I think there are 2 ways in which that doesn't quite match our agreements, and I would like you to consider when you go to revise this. First, we have said that the processing at the ingress edge from the client of how it uses the metrics to decide where to send subscriber traffic is a local matter. Therefore, saying how anything will use the metric, by any given metric by default, other than saying what it means, is out of scope. And conversely, if the metric is not understood by an edge node, the only possibly meaningful default behavior is ignore that metric. Because if you don't understand it, you don't know if you're supposed to add it, average it, turn it upside down, who knows? It could mean all sorts. It's a maximum, minimum. The only thing you can do with a default, with an unknown metric, is ignore it. If you want to put in a requirement, the closest I can see we can come is to note, and it's not even a requirement, it's a note. It is anybody defining a metric should understand that nodes which do not understand it will ignore it. Thank you.
Thanks.
Daniel.
Okay, Daniel Huang, CTE, and I have two comments for the requirements part. When it comes to the traffic steering, actually, we have to assume two criteria. The one is what we have. I believe that's how computing aware networking aware information is about. The second is what the service requires. I mean, the requirements of the service, such as the video service. How much bandwidth do you need? How much latency you want to achieve from it and the end perspective. So I do not say that part of the requirements in the documents. And the second comment is a minor one. And about the discovery of service, the requirements says the CAS needs to associate the service identifier to an address, IP address. I believe it will be, it should be a little better to say associate service identifier to service instance rather than the IP address, because the exposure of the service instance is not necessarily an IP address. Thank you.
Thanks. About the first comment, that I have one more thing to mention, that we had previous discussion on the matrix that some like bandwidth related matrix maybe can be derived to the processing delay. Like we can also use the delay to representing the other matrix. So, but we really to promote the work on the matrix definition, that we hope that people can focus on the work and to give different voices in the list. And I think it's a better way to reach a consensus in the near future. Thanks.
Brilliant, thank you.
Thank you.
So we move on to Yuan Dongyu.
Okay, can you hear me?
We can hear you, yes.
Okay.
And Pong will give you control of the slides.
Yeah, passing the control to you.
Well, it seems it's not my slides.
That's true.
It still casts problem statements.
Oh, sorry.
But you can talk about these slides if you want to. Or do a little dance while you wait.
Yeah, this one.
There you
That's
go.
right. And
Okay, thanks.
Yeah.
Okay, thanks. Well, hi everyone. I'd like to share related work. And according to the feedback of the last presentation in 117, we accepted the suggestions, got more focused on the use cases and problem statements, and updated our draft. Well, it seems stuck that I cannot control it to the next slide, or is there any network thing?
Well, it looks like
Okay,
you
okay.
are changing. Yeah, you are changing the
Okay,
slides.
okay,
Yeah.
okay.
It just takes a few seconds to catch up with you.
Okay, okay. The workgroup use case and problem statement has listed several related use cases. Taking computing aware AR or VR scenario mentioned here, for instance, a more specific condition is further discussed here. Modern cloud-native applications are typically detected as connections to and among microservices, and with each microservice performing an independent piece or functionality that composes a whole application, which might be located across a number of service nodes to achieve scalable use of cloud resources. And a prospective condition with ubiquitous service instances might be predictable. If the premise holds, multiple or even massive instances exist behind a CAS router here. Within the situation proposed here, we may discover corresponding potential problems and risks. Firstly, it should be acknowledged that the computing-related matrix could be diverse and quite dynamic, especially raw metadata. computing delay, CPU load, and bandwidth utilization, for instance, and with the relevant attributes modeled or selected as representatives or related items, it would be a catastrophe for the CAS control plane, which is required to record, update, and maintain massive and frequent variant matrix. Regarding the premise we raised previously, massive instances which lead to a worse circumstance. The number of CAS routers multiplied by average instances per CAS router entries are recorded at any CAS router here. Another problem also occurs that the capability and capacity of a single edge site or a service instance is always limited, and thus achieving load balance among edge sites or service instances would be an indispensable requirement. Here we present a simple condition in which a round-robin strategy is applied. A simple time slot of 10 seconds is allocated for each qualified and applicable service instance. And to simplify the condition, identical weight is presumed here. And then we may place our attention to a remote ingress CAS router here at the bottom of the slide. To select the named or designated service instance, the selection at this ingress CAS router updates periodically, while 0 to 10 seconds for instance 1 and 10 to 20 seconds for instance 2. And suppose same 20 instances located at egress CAS router 1 here. Although the traffic is there to the identical CAS egress in a comparable, stable manner, the selection with instance granularity would change very frequently. As also mentioned in the workgroup use case draft, network path calls in the current routing system usually do not change very frequently. However, matrices that are not oriented towards compute capabilities and resources in general can be highly dynamic. Therefore, an aggregation scheme might be required in CATS. A vivid example is raised here. Let's suppose a service instance with the lowest computing and processing delay should be considered as optimal selection. Other constraints and objects are temporarily ignored here. And for a CAS router has instance 1 to 4 located locally, it may not even be a necessity to expose and distribute all details. It is quite simple because any instance which is not capable of being selected as the best locally has undoubtedly no chance to be the optimal selection globally. And furthermore, if instance 1 always wins to be the local or regional representative, other suboptimal performance among unselected instances is not required to be carried. A representative matrix may also sought to be much more stable. A scheme to calculate the representative performance could be diverse. An average value, a best value, will be determined to expose on demand. There are reckoned to be generalized aggregation methods. About computing related matrix distribution, there are some requirements mentioned in our workgroup's use case and problem statements, which is requirement 8 must provide mechanisms for matrix collection. Requirement 9 must provide mechanisms to distribute the matrix, and requirement 10 must realize means for rate control for distributing of matrix. But as analyzed in the previous sections, a damping method required in requirement 10 may not be sufficient. Correspondingly, we propose our incremental suggestion that should provide mechanisms to aggregate service matrix for distribution. With matrix aggregated, the entries collected, stored, and maintained in the control plane is reduced, and the CAS router only records the information of local instances and the representative entries for the other CAS routers instead of all instances. Local instances plus global CAS routers versus the number of CAS routers multiplied by average instance per CAS router. The result of comparison is quite evident. And additionally, since the entries aggregated, the frequency of entry updates has declined, and the behavior of service route calculation is tempt. So let's review the previous slide with Service instance granularity, a selection as the ingress router updates every 10 seconds. However, with 20 instances located at the same CAS egress, seen as a single representative of a CAS egress, a selection at the ingress router would hold for 200 seconds, which directs to a same CAS egress. And as a conclusion, we here present our incremental requirements for CATS. And for next steps, we are looking forward to any suggestions to refine our draft. And thanks a lot. Any comments?
I put myself in the queue. This is Adrian Farrell, speaking without my chair hat or anything. I think you're making some very good points here, but I would like you to go back and look at the most recent copy of the LDBC CATS framework to see the changes that were discussed in San Francisco and made an update to that draft around introducing something they called the service contact instance, which I think is providing the aggregation of server instances that you're talking about. So I'd like you to look and see how well you fit within that context.
Okay, thanks.
Shirley from Huawei, a simple comment. For me, I read the draft and I see a lot of similar requirements proposed by this draft. And if you know that we have an work item in the in the milestone that we have to finish the requirements and gap analysis draft in the future. So I would like to invite you to work with the authors of that draft to see what can we do together, and let's merge the draft if possible. Thank you.
Okay, thanks. That's just a use cases I want to add to our current WG use case and problem statements, and I'd like to have some cooperation. Thanks.
Brilliant. Okay, moving on. Thank you.
So next we have two presentations about the architecture. First one is Xinxin Yi, please.
Good morning, everyone. I'm Xinxin from China Unicom. My presentation topic is hybrid computing and network awareness and routing architecture for CATS. This is my first presentation in IETF. Please forgive my nervous. My co-author is Peng Ran from China Unicom and Shihang from Huawei. We have know the CATS group is conducting about the computing information and awareness and routing. So I summarized the 3 points. The first is how to aware the computing information, and then the second is to select the optimal service instance. Then the third is how to calculate the optimal forwarding paths after selected the optimal service instance. So above the 3 points, there are 2 typical architectures, namely the centralized model and the distributed model. The centralized model is shown in the left figure. In this architecture, the service instance reports the computing information to the cloud management platform, and then the platform sends it to the network controller. And then network controller select the optimal service instance and calculate the optimal forwarding path, and then send it the results to the ingress router. In this architecture, the centralized system performs the routing decision and which can provide a global perspective. The distributed model is shown in the right figure. In this architecture, the service instance reports the computing information to the egress router, and then the computing information advised between the egress router and the network device. Then the ingress router can select the optimal service instance and calculate the optimal forwarding path, and then it can perform the traffic steering. In this architecture, there is no centralized systems, and everything is done by the network device. Both centralized model and the distributed model have advantage and disadvantage. So there is two problems. Next, please. There is two problems as summarized. The first problem is in the distributed model, a number of devices will be upgraded and the cost will be high because the computing information need to be notified between the service instance and the egress router. The second problem is as business scenarios become more and more diverse, CATs need to be provide different network and computing capabilities for different requirements. So we proposed three considerations. The first is we think should use an easier and less costly way to aware the computing information. And the second is we should to provide enhanced capabilities for demanding scenarios. The third consideration is to provide diverse capabilities for rich business scenarios. Then I explain in detail. Next, please. The first consideration, we should use an easier and less costly way to aware the computing information. We recommend to use the cloud management platform. In this way, the service instance reports the computing information to the cloud management platform, and then the platform can perform some work information intelligently, and then send it to the network controller. And then the controller sends the computing information to the ingress router. In this way, we think on one hand, there is no do not need to report computing information between the service instance and the egress router, so the work is reduced. And on the other hand, the cloud management platform can perform some work intelligently. Next, please. And the second consideration is to provide enhanced capabilities for the demanding scenarios. For example, in the intelligence transportation scenarios, the optimal service instance and the optimal forwarding paths need to be recalculated when the car moves. There is two ways to perform the recalculation. The first mode is the network controller recalculates and then send the result to the ingress router. And the second mode is the ingress router to recalculate directly. In the second way, it can provide a lower delay because there is no transmission time between the network controller and the ingress router. So it can be better meet the requirements in the intelligence transportation scenario. Next, please. The third consideration to provide diverse capabilities for rich business scenarios. According to the previous consideration, to make the routine decision by the ingress router can provide a lower delay. But if all users adopt this way, the ingress router will great pressure. We should provide distribute or centralized routing decision to make the two ways for the different service. For example, in the intelligent transportation, it will be needed to lower the latency. But in the AR or VR scenarios, it may be need a global utilization. So the two ways, the centralized routing decision can provide a global perspective. The distributed routing decision can provide a lower latency. So we proposed to provide a different mode, and you can choose different mode based on the different requirements. Next, please. So we proposed a hybrid architecture to solve this. Its service flow include 4 steps. The first step is the service instance reports the computing information to the cloud management platform, and the cloud management platform process computing information and send it to the network controller. And then the network controller collect the network information and process it along with computing information. There is 2 ways to adopt. If we adopt the distributed routing decision mode, the network controller sends the computing information to the network ingress router. Then it selects the optimal service instance and calculates the forwarding path. And if we adopt the centralized routing decision mode, the network controller selects the service instance and calculates the forwarding path and send the results to the ingress router. Then the 4th step is the ingress router to perform the traffic steering. Next, please. So finally, our next work plan is to promote the comments and the suggestion. Please feel free to contact us if you have any comments, suggestions, and contributions. Thank you.
Thank you, Xinjin. So there was no need to be nervous. That went okay.
Sorry.
There's some discussion been going on in the chat for the meeting, so you can go and read that afterwards. The discussion is about producing multiple drafts in the working group that are raising similar points. And I think it's fine for you to have brought your ideas in a draft. I think that's great. But the end objective should not be that all the drafts are pushing forward and on their own. We should be trying to pull our ideas together and work together.
Okay.
So look, and this applies to other people posting drafts as well. Look at what you're doing and say, yeah, okay, I've expressed my ideas. Now, how can I lift those ideas and help put them into a consolidated merged draft? And merging will not be taking 100% of both documents, because that's crazy. So look at the drafts that are out there, like the existing working group draft, or like the framework draft, and say, okay, how could I take some of my text and put it in there to improve it, and make those suggestions on the mailing list, and then we'll all be happy.
Okay, thank you. I see.
Dongyu, you're in the queue.
Okay, thanks, Adrian, and thank you for your presentation. And I have 2 comments. The first thing that I want to double check that the suggestions you made here is that for maybe delay sensitive applications and services, a distributed framework is suggested, and for maybe resource allocation and a centralized framework is suggested. Is that right?
Sorry, can you repeat it slowly?
Okay, I mean that in your suggestions, with my understandings, that for services that are delay sensitive, may require latency as a requirements, distributed framework is suggested, and for resource utilization, centralized framework is suggested. Is that right?
Yeah. Yes, I mean that.
Okay, and another comment to that, for different service flows, I'd like to see some maybe unified architecture that's granted for maybe devices or orchestrators or controllers? Is there share similar functionality for different service flows? And maybe next steps for the work?
Okay, the centralized system can include the network controller or others, I think.
Okay, thanks.
Okay.
Yes, I can move the discussion to the mailing list. And for this draft, I think there might be some good points based on the existing architecture draft, but hope to work together to move on. Thank you.
Okay, okay.
So,
So Daniel, yes, good. Yeah.
Okay. Daniel Huang, ZTE, and on behalf of authors, I will present Computing and Network Information Value System Architecture for CATS. Unfortunately, there's another architecture, but I have to say we are a lot trying to push a lot of independent architecture. Actually, we're trying to push some additional components for the framework. Next slide, please. The draft has been presented in San Francisco, and what's updated is actually the controller component is updated with and divided into two parts: the control plane and the management. So the workflows of the three working modes has also been updated. Next slide, please. Goals. Yes, we introduced new components and the corresponding interfaces as well as workflows. So we believe it's going to be complementary with the existing framework draft. So we will talk to the authors and see what we can integrate. Next slide, please. As highlighted in the diagram, what's new comparative to the existing framework draft is we introduced a CAS control center, which includes a management plane, control plane, and also there's the two interfaces with cloud management platform and the data plane involved. So when we're talking about the control center components, we designed it to support the fine-grained and dynamic computing information values. Next slide, please. With the employment of the CAS control center, so there's going to be three working modes. We're talking about a centralized model. It's designed for the scenarios where the services are sensitive to the fine-grained and dynamic computing network status, particularly something like latency. And so the network needs to be aware of the detailed computing network information by the centralized model. When it comes to distributed model, the services are supposed to be not so sensitive to the fine-grained computing network. Rather, it's supposed to be sensitive to coarse-grained and comparatively static in the computing network status. And hybrid actually is just the coexistence of the two models. Next slide, please. As far as the centralized model is concerned, as we presented in San Francisco, the CIB and the NIB have been employed to maintain the fine-grained, the coarse-grained, fine-grained computing and network information respectively. And the PCE in control plane is responsible for calculating the service path and delivered to the data plane. So under the centralized model, what's different is in the data plane, it only has the traffic classifier with next slide, please. So accordingly, the workflow also has been updated. Right here, I just want to emphasize this: the service selection policy will be generated by the PCE and delivered to the CAS router. Next slide, please. For the distributed model, right here we can see in the control center there's no control plane right here, the functionality right here, because the data plane part is actually, I believe, quite consistent with that of the IDBL framework. So the only different part is the there's just CATS southbound interfaces which is responsible for report the network computing information to the management plane for the network management purposes. Next slide, please. Accordingly, of course, the workflow of the distributed model was still updated. Right here, actually, as you can see in the diagram, is just only network metric and service metric information has been reported from the data plane to the control center, CATS control center. Next slide, please. Next slide. Okay, when we're talking about a hybrid model, actually we assume there are two kinds of CATS forward. The first one is with routing capabilities on its own, so it can perform the collection of the computing information and as well as the selection of paths. A second class is the CATS forward, which has no routing capabilities. When it comes to the forward without routing capabilities, the service policy will be delivered from the control plane, the PCE, and also the forward with routing capabilities can perform more precise path connection operations based on the instruction from the controller, which maintain fine-grained computing and networking information. Next slide, please. Actually, as I totally agree with Adrian's comments, we do not want to push forward in multiple architecture drafts in the working group. So next step, we would like to coordinate with the existing drafts and talking to authors to see what we can integrate together. As far as the additional parts of this draft, I believe there's 2 points. The one is a CATS central controller, as well as the management and control plane. And second one is the accordingly interfaces synchroned from the central controller with CATS routers. That's all. And comments?
Well, thank you. We have no person in the queue. The same comments with the previous draft. We expect the authors of the architecture draft can work together, and I see there are also some overlaps of the co-authors in different drafts. So maybe it is a good choice for the person to start the action to merge the draft.
We'll bring the points to the mailing list to start the conversation.
Okay, that's good. So next is a gap analysis.
Hi all. There is a long history of the gap analysis file. So I'll quickly go through the update on the gap analysis because it provides some basic knowledge for why CATS is established and how CATS is different from other mechanisms for solving the traffic steering problems. And previously, that the gap analysis file and the requirement file is in the same file, but then we have split the requirement part and merge into the working group document. And so next slide, please. So there is an overall picture of the gap analysis. So there are existing solutions that utilize endpoint resource information for selecting server instances like DNS, Auto, and other layer 4 or layer 7 load balancers. But basically that none of these existing solutions integrate the computing resource conditions with the network and with the network conditions for designing optimum path. So next slide, please. So the first one is a DNS-based solution that for the DNS that the clients will first use the early binding to resolve IP address first and then send traffic. So and the resolver will then check the health of different servers deployed distributedly to make the right decision, grab the right information, and then it will balance the load over the DNS. So for this solution, we have made some updates on the info that previously that the resolving frequency of the DNS is relatively about minutes level. So we have there are some update on the DNS push mechanism because it can offer, it's defined in RFC A765. It offers a relative efficient way to publish computing status information to clients. And so it basically uses DNS stateful operations defined in RFC A490 to give long line, low traffic connection better longevity. It's about like the default keep alive session duration is about 15 seconds, with which we think might be sufficient for dynamic steering, and it's acceptable for refreshing the compute information. But basically that this kind of DNS-based solution still cannot grab the link connection information. Thus integrated decision based on compute load and network status still cannot be derived. So I think this is a major problem, DNS-based mechanism. And next slide, please. And for other solutions like load balancers, basically there are two different options for deploying this. The first one is a single point load balancer deployed at a single site. So we might face a single point failure at the load balancer, so it cannot steer the traffic to the optimal point. And the other one is to deploy different load balancers at different sites. So the problem is still on you cannot select the best site because the decision making is still a problem. And next slide, please. And also the draft compared with auto. The auto work has been explained and also described as Jordi has in previous talk. So I will not go into details into this one because there are still some working on the matrix definition stuff between auto and CATS is still ongoing. So we will keep an eye on that. Thanks. And next slide, please. And also there are some other mechanism like client-based solutions. So that basically is like to expose like a network service providers, expose some network path information, like another like compute information to the clients, let them measure and decide to choose which site they want to deploy their applications. But there is some issue in the deployment and also in in operation level that because the service providers might not be able to or is reluctant to expose their information to clients due to some maybe security issues or other issues. So I think but we also compare CAS mechanism to this solution. So basically these are some major solutions that can do the steering of the traffic things. And next slide, please. So here's a basic summary of the existing gap analysis. So first one is dynamicity. So one more thing I want to clarify on the dynamicity about the traffic steering that in CATS, because we don't want that fast steering like milliseconds level steering, because that seems not ideal. So but minute level minute level steering might not be able to satisfy the requirements. So I think probably about tenths of seconds dynamic scheduling can be acceptable. So we introduced DNS push mechanism, but we also analyze its limitation in grabbing the link information. And also what we need is to combine the information, the network link connection, and also the compute load to make a overall and integrate decision. And that and the other thing we want to consider in the gap analysis is efficiency and complexity and accuracy, and also the metric and exposure and the usage. So this is the overall picture of the gap analysis. So thanks. And any questions about that?
People getting in the queue, but I got there first. Kehan, thank you. I think that the gap analysis, apart from anything else, it's something that our charter tells us to work on. I think it's important, but it's going to be background work.
Sure.
The thing I'd like you to be really careful of is this slide, so that the gap analysis should not be developing its own requirements.
Sure.
If you can be checking that those requirements are properly reflected in the requirements draft, and then you can reference them by number or whatever, and then we won't have surprise requirements coming up in a later document.
Sure. So for the gap analysis, it provides some basic knowledge to build these requirements. So, but according to the charter, it's not, maybe it's not in the milestone of the CATS. So just we want to let people know about this. So thanks. Yeah.
Julien or Julian.
Yes, Julien from Nokia. So yes, I wanted to make the same comment about the requirements. So I've made already this comment last time. I think when we put up requirements, we need to motivate them in some form. For example, by linking them to specific aspects of use cases. And in this case, we don't have anything. These requirements are falling from the sky. The other aspect I would like to address is that I think that some of the solutions that have been presented here are unfairly criticized. I think that, for example, if you're talking about load balancers, I think hyperscalers are using load balancer quite a bit in the internet, and it seems to work pretty well. So you have to be a lot more clear in the criticism you address to them, saying that there are single points of failures with load balancers. It's just not true. It works every day on the internet. If you look at the presentation that you made of DNS, what you're presenting is not quite DNS. It is a system that you have based on some DNS aspects. You're using the DNS protocol in some specific fashion, and then you describe the shortcomings of your solution, not the shortcomings of DNS. So likewise for Alto, you have devised a specific way to use Alto, but what you describe, the shortcomings are those of what the use you make of Alto. So I would encourage you to be a lot more precise on what effectively you ascribe as problematic in these alternatives, because I can devise systems based on Alto, I can devise systems based on DNS that do not have the shortcomings that you point out. So please try to focus on the aspects that are effectively problematic. Thank you.
Okay. Luis.
Hello, this is Luis Contreras from Telefónica. Yeah, in the same line that Julian was commenting and focusing specifically on Alto, you commented the critical aspect is the signal latency. I think that this is a little bit arguable, so probably it's worth to work in more details, as Julian was saying.
Mm-hmm.
Thank you.
Thanks.
All right. Thank you for that. And I think we're at the end of our agenda, unless anybody's got anything else to say about the work and the working group. And of course, I have three things. We've talked about the draft merging issues and the parallel drafts. Please remember your chairs have big sticks. If you are having trouble discussing or merging with somebody else, come to us for help and we will facilitate. There were a couple of presentations where the slide formatting got really messed up. That's because the tools convert your PowerPoint into PDF. As a matter of habit, please, once slides have been uploaded, go and download them again and have a look. Pull the PDF down and have a look and see if it's all messed up. And if it is, we can work to sort it out. And last point, we've just in the last 24 hours received 2 liaison communications from the ITUT, and the chairs have not yet had time to read and process them. You'll see them on the mailing list, and if you've got any comments, then please do send them in. Otherwise, the chairs will work with Scott, who's sitting over there, wishing he wasn't, and we'll try to generate responses as necessary. Anyone else? Last chance.
Was it during the queue, please?
Oh, yeah, Louis. Louis, is that you still in the queue or, yeah? The previous, okay.
Yes, please.
Yeah, I'm still have a few difficulties with the way that the working group is working here, because we've had a few debates on the list in the past, well, 2 weeks probably, but otherwise there's very little happening on the list. And I think that this is not really the way that we should work. I heard the chair ask for people to do a lot of merging activity. I wish that all this was done in the open and that we see more traffic on the list. There's a lot of work. I have said on the chat that I thought that we had far too many drafts for this group. We have, I think, two milestones. Why do we have 23 drafts? So I think that there's a need to work together, and this working together needs to be done on the list and not behind closed doors. Thank you.
All right, I think we're done. See you in Brisbane if your travel budget allows it.
Do you plan to go to Brisbane or still not plan to go?
Still not. Okay. So yeah, we'll discuss it closer to the time.
I do.
Is the mic off? No.
No. Okay. Just to.